Okay, so in this video we're going to be taking a look at the practice problem 5, and this practice problem is for you to gain some confidence into your ability to apply what you have learned. Now, if you have gone through the book, you will most probably see that the question actually has a lot of loopholes, and it is exactly the same as another example question in the book, but this one is in a different scenario, but the questions are basically the same. If you have a better look at it, you can say that. And other than that, the loopholes I'm talking about are not clearly the typo that I have done here. If you look closely, there's a typo. This is supposed to be 50, not 40. Okay, and that's a typo, not a loophole. But if you go over the question and you are knowledgeable of the concept, then you will see that there are some loopholes. It doesn't add up. The story doesn't add up. Anyway, it's an interesting story to look at the example problem that we have done in the book in a different perspective, and also to boost your confidence into using whatever you have learned. So at the very beginning, we have to place our coordinate system, and I shouldn't have given these dotted lines to show you the line of action. It was pretty obvious, but still, I went on and put it there. Okay, so it's pretty obvious where we're going to have our coordinate placed. So this is going to be where our coordinate is placed. So if we place our coordinate in that location like that, okay, so let me redraw the problem here. So here we have a force of 50 newtons. Here we have another force which is also 50 newtons. Then we have another force 10 newtons, and we have another force 20 newtons, and all of them are making a 45-degree angle with the horizontal. Okay, so knowing that, we can figure out the resultant force and the direction of the resultant force, and we have to nullify the effects of that resultant force so that the forces are in an equilibrium. They are not making any effect. Okay, so in order to do that, what we're going to do is we're going to calculate the resultant. So first we have summation f of x, which is the summation of all forces in the x direction. So here we have 50 newton, that is 50 cos 45. There you go, and then another 50 that's on the leftward side right over there, as you can see. So it's going to be negative 50. It's going to be also, sorry about that, cos 45 degrees. Okay, and then we have a 20, and it's going to be also a cos 45 degrees. Then we have a 10 that's on the positive direction, that's also a cos 45 degrees. Sorry about that. Okay, so from there we can get the summation of f of x, which is negative 7.07 newtons. So we now have the f of x. We can write it down here, which is negative 7.07 newton. Let me clear up the space so we can write down the f of y. It's going to be pretty much similar to f of x. I shouldn't have erased it. We just need to change the signs, the pluses and the minuses, and also all of the causes are going to be now signs, right? Okay, so we're doing summation f of y is equals to, it's actually a pretty straightforward problem. If you have gone through all the example problems, this is a piece of cake for you. So we have 45 degrees, and then we have plus 50 sine 45 degrees. Then we have negative 20 sine 45 degrees and negative 10 sine 45 degrees. So the result comes out to be 49.49 newtons. That's almost 50 newtons. So we now also know the f of y. Now we can easily figure out the resultant force and the direction of the resultant force. Okay, just get sound happening. Alright, so for the resultant force, we know the formula, which is root over summation f of x squared plus summation f of y squared, and it comes out to be 49.99 newtons, so almost 50 newtons. So we got one of our answers, that is the person the circus needs to hire must have a pull force of 50 newtons at least, and if it's greater, then we have to ask that person to maintain 50 newtons, and it's going to require some practice, but it is a circus, so they're going to allow him to practice. They're going to help him with the practice exercise. Right, so the person who is going to be doing the pulling must exert a pull force of 50 newtons. So that much we now know. Now we need to know where to place him in this configuration. For that, we're going to need the angle. So let's say we want to figure out the angle. If we want to figure out the angle, let's first drop the coordinate. There you go, this is the coordinate. Let's drop our forces. So it's a negative 7.07, that means it's a leftward force, 7.07, and then we have another force which is an upward force, which is 49.49. Okay, so one is leftwards, one is upwards, meaning that the resultant force is going to be somewhere in the first coordinate, right? Okay, so if it is somewhere in here, we need to figure out the angle, and we're going to get the angle from the horizontal. We're going to get this angle. So if we get this angle, we'll have tan inverse the y direction force, which is 49.49 divided by the x direction force, 7.07, and it is coming out to be 81.86 degrees, 81.86 degrees. So now we have the direction of the resultant, we have the resultant force, and we also now have the direction of the resultant force. Now if we draw that up, let's say this is the resultant force from this configuration. It makes an angle here, 81.86 degrees, and the value of the force is almost 50 newtons. Okay, so if we want to nullify this effect, we need to have a force that's acting on the opposite. Right, so that's going to be a force acting out the opposite, 50 newtons. This is our new guy exerting a force of 50 newtons when the show is going on. And now we need to know, we know that this angle to be 81.86. That means the reciprocal angle here is also 81.86 degrees. If we want to make this simpler, then we can subtract it from 90 degrees, 81.86. which is, let me see what it comes out to be exact. So 90 minus 81.86 comes out to be 8.14. So 8.14 degrees, and that is going to be from here. So straight up from the bottom, an angle of 8.14 degrees. So we can say that an angle of 8 degrees and a force of 50 newtons. So the new guy must be pulling from here. So he can either lay down, or we can shorten the height of the rope so he can stand upright and have the pull on the rope. So your job is done. Your job was to figure out how much force the guy must exert and at which angle. The rest of the things are going to be done by the talent of the circus. They're going to figure out the rope length, how should it be, how long should it be. They're going to have practice exercises with the other guys and the new guy, and then they're going to see how they can put it up right. Yeah, so this was applying what you have already learned to solve a circus problem. And now if you have completed the entire book, if you've gone through the book, if you haven't gotten a copy of your book, you can get the book by following the link on the description of this video. And if you have gone through the entire book, you have done the practice problems, you are looking at the practice problem videos, you have done the practice problems, right? You're doing the practice problems, you will have done the practice problems. Then you can be really confident about what you have learned and the fact that you can actually apply it somewhere. And this problem, this particular practice problem 5 or practical problem 5, will give you a scenario to understand that and to boost your confidence. But also, if when you are done with the entire book, all the practice problems, you can come back to this practice problem 5, read the problem again, and you can see the loopholes there, and maybe you can give it a try to fix the loopholes and move the question around. When you can fix this question, you can guess that you have learned all there was to learn from me and from this book regarding these topics, just these topics alone, without the inclusion of other topics into it. Okay, so that was it. I hope this was a fun exercise for you and you have tried it before looking into the solution video. And yeah, do look into the example problem and you'll see that it is exactly the same thing with a different setting. And you can even find similar scenarios. You can create similar scenarios in different settings, but the case is always going to be the same if you apply this particular knowledge. Alright, so that is it for this video. Thank you very much for watching and I hope you got to learn something new.